In this lesson, we are going to look at logarithms, and as usual, just to remind you how we do mathematics, first of all, make sure that you understand each steps of the examples, and then you do not learn maths by reading it or watching someone else explain it to you. Understanding the steps does not mean that you can do it on your own. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. Then you improve your skills only through practice, but more specifically marking your practice sums and learning from your mistakes. Now we are going to do 3 sections. First one is just going to cover the basic log laws. Then we are going to look at exponential and log form, going from the one to the other and then vice versa. And finally, we are going to solve exponential equations using logs. Now, here we are going to look at the first 2 log laws. The first law says that if I have log of base a with numerical value of x plus log of base a with numerical value of y, it equals to log of base a x times by y. So very important, it has to have the same basis. So if I add 2 logs, their numerical values then multiply. And similarly, law 2 says if I subtract 2 logs with the same basis, their numerical values will divide. Now, just one thing to keep in mind as well, these values cannot be negative. And then another thing is, so the x, y, and a values can never be negative. And the a value can also not equal to 1. Okay, so let's look at some examples. So example 41, expand log AB over C. Now, when we expand, we can see we have a numerator and denominator, and they are divided by each other. So if I expand, I'm going to say log, using the second law, log AB minus log C, because the second law said log x minus log y will be x divided by y. Alright, and then we have this term with a times by b. So we can further expand that to be log a plus log b minus log c. And that is then its most expanded form. Okay, question 41. Expand log u over sq. So we have a numerator over denominator. So I'm going to write log u minus log sq. Okay, and then this term I can further expand, but I must be careful because there's a negative in front of this term. So expanding it, I'm going to use brackets. So log u minus log s plus log q, because they're multiplied. And then I'm going to multiply out the brackets. So log u minus log s minus log q. And there we have our expanded form. Now for a more realistic type of sum, simplify log 16 minus log 8 plus log 2. Now this type of question, there are numerous ways to do it, and with log sums in general, like exponential exponents, there are more than one, most of the times there are more than one way to do it. Now we can do this using law 3, but because we are now busy with law 1 and 2, I'm basically going to use law 1 and 2 applied to this sum. We have log 16 minus log 8. So I'm going to start by simplifying the first 2 first. Log 16 then becomes 16 over 8 if I combine those two, plus log 2, which is then log 2 plus log 2. And this step isn't really necessary, but I'm doing it now just to show you where everything comes from. And then log 2 plus log 2 will be log 2 times by 2. Okay. Also this step, not really necessary, but then you can see that this will then just be log 4. All right, let's look at a question. So simplify log 2 plus log 12 minus log 8. Let's start with the first two terms. They are added together, so you're going to multiply the numerical values. We have log 2 times by 12, that gives me 24, minus log 8. And then log 24 minus log 8, so we divide the value, so that's going to be log 24 divided by 8 is 3. Right, so that was the first two laws, very basic. Now let's look at law 3. So law 3 says when I have log base a numerical value x and my numerical value has an exponent, what I can do is I can take the exponent and I can actually move it to stand in front of the log, like that. So then it will be equal to this. And let's see how we can apply it. So example 43, expand log 81. Now remember with exponents, because remember log is just the inverse of an exponent. With exponents, when we have bigger numbers like 81, what we normally do is we prime factorize them and then we work with the bases and the exponents. Now same with logs, we can always take our bigger values and then use our log laws, apply our log laws to our bases and our exponents. So this becomes 3 to the power of 4. Okay, now we have our numerical value now has an exponent, which we can now take to the front, and this will give us 4 log 3. Right, expand log 121. So first of all, let's just prime factorize. That would become 11 squared, and then we can take the exponent, put it in front of the log, and this will give us 2 log 11. Example 44, simplify. All right, so we expanded in the previous one, so let's now simplify. We have this 3. Let's maybe just write this out first. 4 minus 3 log 2. So I can take this value now and put it as the exponent for my numerical value. This becomes log 4 to the power 3 minus log 2 to the power of 3. This then becomes log 64 minus log 8. And now these two logs are subtracted, so the numerical values will then divide, which leaves us with log 64 divided by 8. So that's log 8. Right, question 44. So the same applies here. We can take the value in front of log and put it as the exponent of the numerical value. This will give us log 5 to the power of 2 plus log 2 to the power of 5. Let's work that out. This is going to be log 25 plus log 32. And then when these are added, we can just multiply 25 times by 32. So let's do that on the calculator. So that's 800. So this is going to be log 800. Okay, law 3 done. Let's look at law 4. And law 4 says that if I have a log with base a, numerical value x, I can expand it and write it as log x over log a. Now when we do that, remember these then they do have a base, but when a log does not have a base, it will be to the base of 10. Okay, that's the same as where we normally would say x. If I write x, it actually has a 1 in front, so it's actually 1x, but we don't write 1x always. And it also is to the power of 1, but we don't write x to the power of 1. That's the invisible one, and it's also actually over 1. So all of this is actually happening, but we don't write it. So in the same way, when you just see log, there is actually, it actually has a base of 10, but we don't have to write it. Okay, so example 45, simplify. Right. Now looking at or thinking about, like I said, there are many ways to solve this. We could use law 3, but since we are on law 4, if I have log 4 base of 2, then I can rewrite it as log 4 over log 2. Okay, now I can actually put this in as log 2 squared over log 2, and then I can apply my third law, take the 2 over to the other side. This becomes 2 log 2 over log 2. We can cancel, and then we have just 2 that's left. All right, now from here, if we look at this, if we saw that this log 2 with base 2, this we can expand as log 2 over log 2. Now this means, what does this mean? And if this cancels, this is equal to 1. All right, so this actually tells us that if you have a log and the base is the same value as the numerical value, this is actually just equal to 1. So for reference for the future of this video, if I ever get this, I'm just going to say it's equal to 1. I'm not going to write it as log 2 over log 2 and then cancel and then 1. So this is where it comes from. This is why same base, same numerical value, so then it is equal to 1. Right, so furthermore, log 100. Now here's an exception. Now normally, like what I said earlier, when you have a big number, just put it in its prime factors. But when you have numbers 10, 100, 1,000, 10,000, and you're working with logs, it's always better to first just try and put them to the power 10 to the power something, because remember we said earlier that a log actually has a base of 10 always. So it would make more sense to write this as 10 squared instead of writing it as 2 squared times 5 squared. So then after this, we can just take this exponent, put it in front. So we have 2 log 10, and then because this has the same base, it's going to be equal to 1, log 10 over log 10, so this is equal to 2. So this also tells us actually that log 10 is also just equal to 1. Right, now let's look at a few mixed questions. These questions are more the type of exam type of questions that you can expect. Okay. Question 46.1. So now remember we have 4 laws. You can play around with those 4 and see what final answer you can come up with. Hopefully the right one. But here we have a bigger number, so I'm going to start by prime factorizing that. Now, yeah, there's 2 ways. We can either like add them first and then multiply the numerical values, or we can just start by putting them first in prime numbers. So I'm going to just start by putting them first in their prime values, or prime numbers, prime factors. Okay, so log 2, so 128. Let's just prime factorize that. So we get 128 is equal to, then I say shift fact, so that's 2 to the power of 7, plus, and then 8 is 2 to the power of 3. Okay, so here we have now exponents, so I'm going to take the exponents, put it in front of log, so 7 log 2 base of 2 plus 3 log 2 base of 2, and then this is equal to 1, that's equal to 1, so we are basically left with 7 plus 3, and that gives us 10. Once again, let's see. In this case, 125 and 25 kind of divides nicely. So in this case, I'm going to subtract the two logs first. So it's going to be log base of 5, and then 125 divided by 25, so that gives me 5, over. This is just subtract 125 minus 25, so that's log 100. Okay. Next, this part here becomes 1 because it's the same base and the same numerical value. This one I'm going to change to log 10 to the power of 2. Okay. Take the exponent over. So 1 over 2 log 10. Then we saw log 10, same base, so that's going to become 1. And our final answer then is just a half. Alright, next up we have the sum. Now we must be careful, these bases are different. Now that means we're not really going to be able to add these. What we can do then, and especially when the bases are a little bigger, then we're going to apply law 4. So log 16 over log 8 plus log 27 over log 9. Okay, prime factors, so 2 to the power of 4, then that's 2 to the power of 3, then we have log 3 to the power of 3 and log 3 to the power of 2. So basically now I just put everything in their exponential form or in their prime factors, and then we can use the third law, taking the exponent of the numerical value and placing it in front of the log. So 4 log 2 over 3 log 2 plus 3 log 3 over 2 log 3. Okay, so this just conveniently cancels out. Okay, and we are left with 4 over 3 plus 3 over 2. And we add. So let's get our calculator and just type it in. So 4 over 3. And this is what is nice about grade 12. You do not have to use, like in grade 9 where we have to add it using lowest common denominator. So 17 over 6. Right, next up, 46,4. Alright, now we can see we have log 0,01 to the power 3 plus log 0,01 to the power 3. We can start and because they are identical, so what we do here we'd probably do there, but to make our work a bit less, what I see there is something like x to the power 3 plus x to the power 3. So instead of working through a sum and doing things twice, why don't we just add them because they are identical, and this would then be 2 x to the power 3. So replacing x with this log 0,01, I'm going to first add them, so it's 2 log 0,01 to the power 3. Now just be careful here, this 3 is not, this 3 is the exponent of the entire log, alright? It's not the exponent of the numerical value, so I'm not allowed to take this 3 and put it there, because it's actually a power of the entire log. Okay, now another thing I remember in maths is if it's easier to work with fractions than decimals. So when you see a decimal, I think just convert it to a fraction. So let's do that. Log 1 over 100 to the power 3. Okay, there we have 100. So let's take that to 10 squared. 10 squared. And then what we see is we want our bases to be on top. So to get this base up, my base goes up, my exponent changes sign. This is 10 to the power of negative 2. All right. Then what will we do then? So then this can now, this is now the exponent of the numerical value, so that goes and stands in front of log. So 2 minus 2 log 10 to the power 3. Log 10 we saw is equal to 1, or that's just because they're at the same bases. They cancel, so we are now almost done. So minus 2 to the power 3. Now we can apply the exponent to this value. So 2 times by negative 8. That's what negative 2 to the power 3 is. And that becomes negative 16. Okay, then question 46.5. Right, well, our bases are again not the same and they are a bit bigger, so I'm going to apply law 4 and say log 2 over log 8 plus log 5 over log 25. Right, prime factorize. We can prime because we can see that is log 2 and there's base prime factor is 2 to the power 3. There's log 5. Prime factors are 5 squared. So we can see kind of where this is going. Log 2 to the power 3 plus log 5 over log 5 squared. Okay. Then law 3, take the exponents to the front. Log 2 over 3 log 2 plus log 5 over 2 log 5. Right, then we cancel and we type in, or we have 1 over 3 plus 1 over 2 left, and then we just add our fractions. Five over 6. Done. Right, 46.6. Now here we see we have 2 log base 2, 3 plus 2 minus log 2, 18. So just be careful because this is one term, this is one term, and this one term. So obviously we're going to simplify the terms on their own and then just add them. Okay, so here we see that we have 2 logs with the same basis, so I think it will be easier to start by maybe subtracting the 2, but we have a problem. The bases are the same, but we have a 2 in front of this one. Although it's not really a problem because we can just take the 2 to the exponent, then we're allowed to basically subtract them. So the first step, what I'm going to do is I'm just going to take the 2 over, and then I'm going to just rearrange these 2 because I want to subtract that. So this is going to be log base of 2, 3 squared, minus log base of 2, 18, plus 2. Okay, then this becomes 9. So we have log 9 minus log 18. This is now base of 2 plus 2. And this becomes log base of 2, but then 9 minus 18, so the numerical values will divide. So 9 over 18. Okay, we still have that plus 2. Okay, this then just becomes half. Okay, so this is log base of 2 half plus 2. Okay, what now? We can make this base, or take it up, because this is to the power of 1, so make the exponent negative. So we have log 2 to the power of 2 minus 1, 2 to the power of negative 1 plus 2. Okay, now we have an exponent we can just take over again, minus log 2 base of 2 plus 2. This becomes 1, same base and same numerical value. Then we have minus 1 plus 2, and that gives us 1. Right, next up. So here the easiest is definitely going to be to apply like law 1 and 2. So divide the first one. So log 9 divided by 3 is 3, and at the bottom, or the denominator, 9 times by 3, so that's log 27. Alright, so let's put that in prime factors. Log 3 over log 3 to the power 3. So this exponent comes over. So log 3. So 3 to the power of log 3. These cancel, and we have 1 over 3 left. Okay, so that was log laws. And next, let's look at how to take exponential forms to log form and back. Alright, so when we have an equation as follows, we have a to the power of x equals to y. Now, let's just color code that quickly. So a is my base, x my exponent, and that's equal to y. Now, when we are talking about logs, logs are basically like the inverse of exponents. And we can take this form and change it into the an equation equivalent to this, but in terms of log. Now, the way that is easy to remember is we know we want to go to log, so we write down log. Now, a is your base over here. Now, if it's the base in this equation, then just remember that base stays base. So then make a, if a is there, the base, make a the base of log. Then the next thing to remember is if a was with x, then put it with y. So then the numerical value of log will then be y, and then you just say equals to x. Alright, so two things, base stays base, and if the base was with x, put it with y. If the base was with y, then put it with x. And there's your log form. So then we can look at, if we have our log form, how do we put it back into exponential form? So once again, it's color coded. And remember, same thing, base stays base. So we write a. And also, if a was with y, now you put it with x. So now you say a to the power of x is just equal to y. Okay, now let's apply this to some numbers. Write the following expression in log form. Now we have y equals to 5 to the power of x. So base stays base. So 5. So I write down, I'm going to log form, so I'm writing down log. And base stays base. It's with y here, so it's with x here. So in my log form, it must be with y. And then it's equal to x. And there we have it. Okay, so we write the following. I want to go to log form. My base is 7, so that's going to be my base there. And then over here it's to the power of 2, so now I'm going to make my numerical value 49 and equate it to 2. Okay, write the following expression in exponential form. So now going from log form to exponential form, we have a equals to log 7b. So base stays base, so 7 is my base. And then since 7 in this side is with b, now it goes to a, and it is equal to b. Okay, write the following expression in exponential form. Let's just write this here. Log base of p, numerical value 5, equal to q. Base stays base, so that's p, right? And then it's now going to be with q, and it's equal to 5. All right, so that was it, short and simple. Now, it seemed like a bit of a useless activity, but in the next section, we are going to see where we're actually going to use it. Because when we have equations that is either in exponential form or log form, we can basically convert it to the one or other to solve for it easier. So let's look at what that looks like. Okay, so solve for log 4, 8 equal to x. So log base 4, numerical value 8 equals to x. Okay, so this, if we don't have like maybe a calculator, this is, okay, if you have a calculator, you can type it in, but let's say you don't. So then base stays base. So 4 to the power of x is equal to 8. Okay, so that's our exponential form. And then we know with exponential equations, get them to the same basis. So 2 to the power of 2x is equal to 2 to the power of 3. We drop our bases. 2x is equal to 3. Divide both sides by 2. So x is equal to 3 over 2. Okay, so this is actually like a more practical thing where we want to convert to, definitely want to convert to exponential form. Okay, so my base is now x. Okay, and it's going to be now with 4 to the power of 4 and equal to 625. All right, now this isn't an exponential equation because the unknown is not in the exponent, but so solving for this, we can just see it's to the power of 4, so you're just going to take the 4th root. So this is going to be x equals to 4th root of 625, and that is then equal to shift, that's 4, 625, and that's equal to 5. Okay, so plus or minus 5. Right. Then for the following one, we can now take it to, so base stays base, so we have half, and then it's going to be to the power of x is equal to 32. Okay, both of these we can take to a base of 2. 2 is we can just take that base up and make it 2 to the power of -1. X equals to 2 to the power of 5. Then simplify, minus x equals to 2 to the power of 5. Drop the bases. Minus x equals to 5. And then divide both sides by -1. So that's -5. Right, here you need to remember that when a log doesn't have a base, it is to the power, the base is 10. So there's actually a 10, so to change this, it's going to be 10 to the power of 1 is equal to x minus 3. Okay, this is then just like a linear equation, x minus 3. Take the 3 over, so 10 plus 3 equals to x, so x is equal to 13. Okay, now let's look at exponential equations that cannot be changed to the same base. And this applies a lot, or it has a lot to do with finance, where we want to find the number of years, which is normally in the exponent. And yeah, it's normally random, so we have to use this method when it comes to finance sums, and you have to solve for n. Okay, so this is much simpler than the type of finance sums we're going to look at, but this is just to give you the idea. Now you can jump straight ahead and put it in its log form and solve for x, although this is what we're going to do when we have 3 to the power of x equals to 42. And the thing I'm going to do now, this is where you're going to see where or how we manually put it in the log form, like how it happens that it goes to that form. So remember, what you do on the one side you can do on the other side. So in this case I'm just going to log both sides. Log 3 to the power of x equals to log 42. Right, then I'm going to use law 3 and say this x goes in front of log, so x is equal to, or x log 3 is equal to log 42, right? And now x is on its own, sort of. We can just easily get rid of log 3 by dividing both sides by log 3. So x is equal to log 42 over log 3. Yeah, and then from here we just type it in the calculator. So here we can just write okay, so our answer is 3.40. You can write 3.4. Okay, now just one thing. This we could also, if we had taken it directly to the log form, this would have just been like log 42 with base 3. See, base stays base, and then it's going to be with 42, and that's going to be equal to x. So yeah, that's just doing it manually. Right, so first thing, log both sides. Or, well, actually first thing is see if you can get it to the same basis, but we know this won't work now. 28, log 28. Okay, take the x over, so x log 4 equals to log 28. Divide both sides by log 4, x equals to log 28 over log 4, and that then we type into the calculator. Okay, so that's equal to 2.4, and we are done. Okay, so that was it.